Bismillahirrahmanirrahim. Dear viewers, today I will show time-saving procedure to create foundation column layout, footing schedule, column schedule using Etabs node reaction and Excel sheet. This is helpful for the projects where maximum footings are single, but you can create new Excels for different purposes using the formulas used in the Excel sheet I have prepared. This is simple to use. You don't need to know programming or visual basic. Just Excel knowledge will save your lots of time. Now come to the point. Normally what we do after beam column layout, we create model for analysis. Then we do design beam and columns. After beam column design, we need to design footings and we need to create foundation column layout with schedule. One by one, column and footing labeling and then scheduling is time consuming. How it will be if we can create all labelings schedules in simple procedure. After designing beam columns, we will copy the column layers for creating column foundation layout. After finishing beam column design, we will copy the column layers to create foundation and column layout. We can do it very easily using Etabs reaction value in the Excel sheet. See here, copy this one, then paste here. Here at 00 coordinates we will get the labelings. We can match the text properties of columns. Then we can move this one here like this. This is column labelings according to the foundation reaction. Now footing label, copy this one, here just paste like this. We can match the text properties, this one for footing. Then we can move this one to here like this. Then we can create foundation size, footing size, this one footing size, copy this one, then just paste here. This is the footings. We will match the footing layer, then we will move it here. Now this is our column labeling, footing labeling and foundation layout. Here we just need to adjust the foundation positions. This I will rotate to match with the column direction. This one I will move it here like this. If you need to change the column size, you can do it. First we will create column table, copy this one, then paste here, and here our column types are up to C5. So we will copy C1 to C5. Here are the numbers 1 2 3 4 5. Then paste here like this. Move it here. Extra cells we can delete. Okay, according to this size we can change our column size, then we can reposition our footings. For example, this is C3 here 200 by 500. We will check. This is 0.5 meter, that means 50 centimeter. So this is okay. Now we will position our footing to column center. And footing schedule we can create from here also. Just copy the cells, paste here, then we will see the footing types up to 11. So here are the numbers 1 2 3 in this way up to 11. Copy this one, then just paste. So this is our footing schedule for single footings. If any footings are overlapping, in that case we will make that combined footing. So for other project I will show this procedure from beginning to the end. This is our model. Here lots of columns available in this project. So if we do one by one column labelings and footing labelings, it will take too much time. So now how we will save our time? See here. Here are the foundation, reaction. Go to tables, analysis, result, reaction, joint reaction. Here filter the load combination, dead load plus live load. Vertical reaction, that means FZ. Copy this one, or you can press Ctrl plus C, then come to here. Here for footing and column labelings we have to provide input. Here just click on this cell, then paste like this. Now we will sort ascending from lower reaction to higher reaction value. Now copy this one, click on this cell FZ, then paste like this. So these two reaction values we need for our column and footing labelings. Now from here copy this one, then we will paste here as value. Okay, this one we will copy for column also, paste here as value. First we will create our column schedule. Here from our design calculation we have created range for our column schedule 0 to 200. Long dimension of column 300 mm, short dimension of column 200 mm. Ribbon number 6Y12, that means 6 number of 12 mm dia bar. In this way, above 200 to 350, the column size will be 200 by 400. Here are the size of column. So we will get our size from this load range. Now what we will do, we will choose maximum reaction value for a single range. For example, 0 to 200, here there are two reaction value from 0 to 200 range, 120 to 179. So we will keep maximum on. Copy this one, paste as value. Okay, delete this one. Now this 346, it is in the range of 200 to 350 kilonewton. So copy this one, paste, delete this one. Now the next range is 300, above 350 to 600. So within this range there are lots of reaction value. Maximum one is this 600. Copy this one, paste here. Now delete this. Now next range is 600 to 760. So here we have these values from for that range. So maximum one we will take 744, paste here. Delete this. Then above 760 to 1000 kilonewton, this one maximum, copy here, paste, delete this. Now next range above 1000 to 1250, here this one the maximum, this copy, paste as value. So these three we will delete. Next range is above 1250 to 1500. So these two values are lying in between the range. So maximum one, copy this one, paste as value, delete this, and last one, copy, paste as value. Now we have got our column types C1 to C8. Now we can drag these cells up to this one, from here to here. Okay, last one we can type here 1590 above this maximum value to 2000 or anything we can type, so that cell can find the range and accordingly it can find out the column label. Okay, now our column schedule done. Here we will go for foundation design. This foundation design as per IS code, I have done it horizontally. Here we can choose our range according to our choice. I take the range from 0 to 50, 50 above 50 to 100, above 100 to 150, like this. Intervals is 50 kilonewton. First value is 122.4. So within the range of 150 kilonewton, here is one value, this one. This one 179.8. This is lying between above 150 to 200 kilonewton. 346.4 kilonewton. Here it is lying in the range of 300 to 350. So this single value we will keep. Here 382.9, this is in the range of 350 to 400. So this also we will keep. Now here we can see 408, 430, 444. This three value is lying in the range 400 to 450. So I will take maximum one, copy this one 444 and then paste here, so that these three footings can be a single type footing, that is F5. This one F5. Okay, now above 450 to 500, this one value we will copy here, paste, delete this one. Now 539, it is in the range of 550, copy and paste. Now this one 562 and 600, these two value in the range of up to 600. So copy this one, paste here. Now this one, these two values in the range of up to 700 kilonewton. So this maximum one, copy here, paste here, delete this. Now up to 750, these three values, maximum one 744, copy this one, paste here, delete. Then here up to 800 kilonewton. These two values, maximum on copy, paste here, delete, then up to 950, this one, up to 1000, this one, up to 1100, this one, copy, paste here, paste here. First time you will need some time, but when you will be used to this process, you can do it faster. Copy this one, paste, delete, this one up to 1400, and last one, this one up to, this one in the range up to 1600, delete. So we have got foundation type 18, F1 to F18. This is input cell and this yellow color is output. In the yellow color we don't need to provide any value. Here soil bearing capacity 150 kilonewton per meter square according to the soil report. So this one will be same for all the footings. We can see the required area. Accordingly we can provide the size. So it is showing okay. Concrete strength, I will choose 25 MPa. According to the punching shear check, the required depth 92 millimeter. We will use minimum 300 millimeter footing depth according to our code recommendation. This in short way, and the use rebar, this 12 millimeter dia bar long way. So according to the calculation, here inside the cells you will get the calculations. Now required spacing is 225, we will provide 200, okay. Here 228, 200, okay. And here one way shear check, this is also okay. So F1 done. Now come to F2. Generally we need to design all the footings separately. Maybe we will have separate footing excels, so that will be time consuming. We will do it in a single Excel sheet at the same time, then we can get footing schedule very easily and foundation layout, column layout very easily. Now F2, here the required area, this one we will provide smaller 1.2 meter by 1.4 meter. So this is okay. 1.32 square meter required, here 1.68. We can reduce more also, 1.3 we can provide, 1.56. okay. Here we can also provide 300 millimeter depth. Short way we will use 12 millimeter dia bar, long way 12 millimeter dia bar. Here also we can provide 200 millimeter spacing, 200 required is this, one way shear check, okay. Now third one, here required area 2.54. Here if we provide 1.6 by 1.8, then it is coming 2.88. So provided area is okay. Depth here required 224. Here we can check with 300 millimeter depth. If we provide 300 millimeter depth, then it is failing in one way shear check, it is showing not okay. So we will go for 350 millimeter depth. Now for 12 millimeter dia bar required spacing is coming 187, 189, long way we will provide 180. So now F3 done. F7 done. In this way we will finish all the footing type up to F18. We have finished our footing design according to the foundation reaction. Now we will finalize our footing leveling range from here to up to 18 and here from this value to this, then above this 1589 we can write 1590 to upper range any value 2000 or 2500 any value. Okay, up to this up to this one up to F18, same way this one up to this then this up to F18. Okay, we have balanced only the coordinates for positioning the column level, footing level and footing size drawings. So we will go to Etabs model. Here we will get the coordinates of foundation nodes. Go to model, structural layout, joint coordinates, show table. Here we will filter the story. We will go to the base level. Here X and Y coordinate. Control C. Then these two cells select, paste like this. Now this one we can drag like this. You can drag like this. Okay, so our procedure done. Now we are ready to draw our labelings and schedule. Now go to this project. We will copy the columns from here to here. Now go to the Excel sheet. First column labels, copy this one, finish. We are showing this project, paste here like this. Just we can match the properties of column text, then we can move. Okay, now go to footing label, copy this one, paste here, match the footing text layer. Here we can draw footing size, copy, paste like this, then we can move this to here. Now we will create column schedule. Here our column types C1 to C8 and footing up to 18. So for column schedule, copy this one and paste, and here this is the column number 1 2 3 4, so up to 8 we will copy. This is up to 8, paste here, then we can place it to here. Similar way for footings, copy and paste here. Types of footing up to F18, so here this side you can see 16 17 up to 18. Copy this one, then paste. Okay, this done. Now we can rearrange our foundation position and column size. This one C5. Here you can see C5 200 by 700. We will check this one how much. This 50, so we will increase it 20 centimeter, 0.2, like this. Now we will rotate the footing to match with the column orientation. Then move this one to here. In this way we can rearrange the footings and we can finish our procedure. If you try this procedure after 2-3 projects, you can do it more faster way, as I usually do in my office projects. So if you need this Excel sheet, you can get it from my website decode-bd.com. From here you have to go to the resource page. Here still I have not uploaded. I will upload this one now. Then you will get the Excel sheet here in recent and also in the category of Excel sheets. To make this Excel sheet, I have given lots of efforts in more than 2 months. So for this Excel sheet, you have to pay more. Thanks for watching. Stay tuned for more upcoming important tutorials.
Press the bell icon on the YouTube app and never miss another update.